Hi, David Cam here with another question from your Hayes and Harris Math SL textbook. This is chapter 10I.2, question 3G. In this question, we're given an expression and told to show that it simplifies to this much smaller expression with only one fraction. Now, the path is not obvious at first, but there's a couple of things that I notice. First is that I have two fractions here and only one fraction here, which tells me that I'm going to want to combine the two fractions. The problem is that the two fractions have different denominators. So I'm going to have to make them have the same denominator somehow. The way to do that is to multiply each fraction, numerator and denominator, by the denominator of the other fraction. I'll show you what that looks like. Let's start with 1 on 1 take sine of theta plus 1 on 1 plus sine of theta. So this is just the same expression. What I'm going to do on this side is multiply by the denominator of the other fraction, 1 plus sine of theta. So I want these two expressions here, this one and this one, to multiply together. But to do that, in order to keep the equation balanced, I need to make sure that I multiply the numerator and denominator by 1 plus sine of theta. 1 plus sine of theta divided by 1 plus sine of theta is just 1, and multiplying by 1 does nothing. So I haven't imbalanced the equation as long as I affect the numerator and denominator equally. I'm going to do the same thing on the other side. I'm going to multiply by the denominator of the other fraction, 1 take sine of theta, on the numerator and denominator. Now what does this do for me? Well, if I multiply the numerator in, 1 times 1 plus sine of theta is 1 plus sine of theta. Same thing on this side. 1 times 1 take sine of theta is 1 take sine of theta. But what happens in the denominator? This is where the magic happens. In the denominator, I have 1 plus sine of theta times 1 take sine of theta. That's difference of squares. That's 1 squared take sine squared. And it's the same thing on the other side. 1 plus sine of theta squared times 1 take sine of theta squared. Difference of squares, 1 squared take sine squared. You notice that 1 squared is the same thing as 1. Now what I have are two fractions with the same denominator, which allows me to add their numerators. 1 plus 1 is 2, and sine take sine is 0. So it's just 2 in the numerator. In the denominator stays the same, 1 take sine squared of theta. Now I have one fraction, like I have over here. The only trick left is to convert sine into cosine. And since I have sine squared, I think I'm going to try and use sine squared plus cosine squared equals 1, this identity. If I bring sine squared to the other side by subtracting, I get 1 take sine squared of theta is equal to cosine squared of theta, which is what I have over here, 1 take sine squared of theta. I can make that substitution, and I get 2 on cosine squared of theta, which is what I was asked to show.